Hello everyone, and welcome to our talk on Zero Trust Maturity Assessment using OSCAL and open source tools. My name's Donald Hunter. I'm the security team lead within the Office of the CTO Emerging Technologies team at Red Hat.
And I'm Arthur Savage. I am on the security team as well, doing post-quantum cryptography.
And I'd like to give a shout out to Nathan Strass, who did a summer internship with us, and the application we'll be demoing at the end was written by Nathan during the internship. Okay, so these are the topics we're going to discuss today. And just before we start, a quick show of hands who understands Zero Trust? Who understands compliance? A few, very few. And has anybody heard of OSCAL? One or two. Okay, interesting. So we've got a newbie audience for some of the topics. That's brilliant. Okay, so just to recap for level set everyone in the room, what is Zero Trust? So the traditional view of security in deployed systems was the perimeter model, firewalls and things like that, and everything within the trusted perimeter just had assumed mutual trust and could talk to each other. We've moved on from that. We've moved from macro segmentation to a micro segmentation world, where with things like service mesh and kube network policy and things like that, then we've got a much more segmented view of our architecture. But there's still mutual assumed trust between workloads in a cluster or in a deployed system. So you don't necessarily, you assume, again, you can trust the database that you're talking to, for example. Or if there is some authentication, very often there's stored secrets and things like that. And so what we want to do for a full Zero Trust architecture is move to a model where every single workload and every single actor in the system has to prove its identity before anything will talk to it. And so this is like a model where you do not assume any trust and you always verify. And in order to do that, we need to establish some foundations in our system, workload identity, tracking user identity, defining policy about what is allowed to talk to what. And in order to embark on implementing Zero Trust in deployed architecture, we need to have a model of how we want to visualize what we're trying to achieve. And typically, Zero Trust is viewed in pillars, separate pillars of things that you need to implement to achieve a full Zero Trust architecture. And typical pillars, there's a 5-pillar model where we have identity, device, network environment, application workloads, and data as being the pillars. And then there's typically foundational pieces such as visibility and analytics and automation and orchestration that really drive how Zero Trust gets implemented across the main pillars. And there are several open source projects that already deliver on many parts of this. So you've got Keycloak as an identity provider, you've got Istio as a network service mesh, you've got OPA policy being built into many of the components in the CNCF ecosystem. Now, there is another view that you can take. The Department of Defense in the US, for example, goes for 7 pillars of Zero Trust. And you'll notice the difference really between this view and this view is that automation and orchestration and visibility and analytics have become pillars rather than foundational. Now, it doesn't really matter what view you take, as long as you take a view when you're going to deploy your Zero Trust in your organization, so that you can approach the problem on a pillar-by-pillar basis and decide what components or solutions are you going to build or deploy in each pillar to achieve the Zero Trust outcomes you want to achieve. And with that in mind, when you're assessing how you're going to approach implementing Zero Trust, for each of these pillars or domains that you need to implement something, you're probably going to take a very different path to achieving like optimal implementation. You'll start from where you start. You'll have your traditional security model. You'll gradually improve your posture, and you'll get to an advanced security model and eventually optimize. But you'll go through the journey at different paces for each of the technology pillars. So, for example, a lot of things are built on identity. So you'll start by building out some identity capability. You may be able to very rapidly build network segmentation, but that will only take you so far until you've got a full identity model across your entire cluster, so you can go that last mile of optimizing how you do your network isolation based upon workload identity. And that just lets you know that the path that you'll take will vary, and it will vary by organization. So it's very difficult to give concrete recommendations about how you proceed. It's an organizational view that you need to take And in order to move along this journey, you've got to ask yourself, well, where am I now? And you need tools to be able to measure where am I going and am I making progress? And so one approach, and this is an approach that Red Hat takes, is you start out with a customer survey. So our sales engineers or field engineers do this with our customers. You know, it's a manual process, walking through with the customer, assessing what the customer's current capabilities are, what the customer thinks they may be able to implement in first steps of a zero trust journey. Now, this is great, but it's very ad hoc. It's not very repeatable, and it doesn't really give you a continuous assessment view of how you are making progress on a zero trust deployment journey. So what we've been exploring at Red Hat is, can we take advantage of existing open source projects and content that's been developed in the space of compliance in order to provide some automation tools, provide some visual feedback to people that are deploying our systems so that you can measure the progress you're making in your zero trust deployment journey. And one of the biggest bodies of work that we have in open source from Red Hat is a project called Compliance as Code. And in the Compliance as Code project, we have enumerated a lot of ways of measuring a deployed cluster using something like Compliance Operator to report on whether or not we're meeting compliance goals across various regulatory regimes, such as HIPAA or PCI DSS or Department of Defense targets for compliance. And with that information, we've already automated measuring how various components in a deployed system are operating. And in many cases, there's also Ansible scripts that can remediate things that are not correctly deployed. So this is a super useful corpus of information that can be used and used for automation in deployed systems, especially in the Kubernetes environment, that we can leverage in a novel way to try and assess and give visual feedback on where we are from a zero trust maturity posture perspective. There's also a set of tools that have been being developed called Comply Time, which aim to modernize some of the ways in which this kind of work is done and make it interoperable with projects that are being delivered by other companies across the CNCF ecosystem. And so what we're going to demonstrate later in the talk is how we're making use of this to adapt it to our zero trust goals. And we're bringing in a couple of things that are developed specifically to achieve that. One of those things is the Zero Trust Catalog, which I'll talk about in a minute once I've introduced some of the concepts from OSCAL, which I'm going to mention on the next slide. And the thing that we developed specifically for this is the Zero Trust Visualization app, which is upstream in the Red Hat Emerging Technologies Git space. So what is OSCAL? OSCAL stands for Open Security Controls Assessment Language, and it's an attempt to modernize all of the frameworks that have existed before for doing compliance work. For anybody that does know anything about compliance, there's a bunch of legacy technologies like SCAP and XCCCDF and so on that are all combined together, but they're all very piecemeal and they don't work well together. And the resulting solution is you can't really write interoperable tools for automating compliance processes. So OSCAL was developed in order to achieve better outcomes and make it possible to develop better tools. And Red Hat's been working very hard in the background to make use of OSCAL to modernize its compliance infrastructure and also to provide some tools that will help our customers deploy zero trust in deployed architectures. And the way OSCAL works, it's a description language, but it's a description language that aims to meet the needs of various different actors in an organization or in the entire compliance process. So for example, we have a controls layer where we define catalogs of controls that need to be satisfied for compliance or for zero trust. We have an implementation layer where organizations define what they want to achieve in their compliance regime and what controls they're going to implement to do that and what manual processes and so on. And then we have an assessment layer where automated tools actually measure the system and manual processes are used to do the pieces that automated tools can't do. to build an assessment. And then ultimately, when you're actually targeting compliance, then there's an auditor comes in and reads assessment results and decides whether or not your deployed system is in compliance or whether there are actions and milestones that need to be carried out to bring your system into compliance. If all you're doing is trying to implement zero trust for your own needs, then the assessment piece is largely not important at all. But the implementation piece and the controls can be very useful from an assessment perspective, as we're going to show. So OSCAL, just a slightly different view of what OSCAL delivers. On the left-hand side here, we have catalogues of controls. And it's typically regulatory organizations that define catalogues of controls. So NIST has defined the SP 853 catalogue of controls. The CNCF has got its own cloud-native controls. Then CIS has got its set of cloud security controls. So there's various different organizational bodies are defining these are the things that you need to implement in order to achieve certain security outcomes. And then profiles are written both by regulatory organizations and by adopting organizations. So companies deploying zero trust or implementing compliance policy will decide what subset of controls they want to actually implement in production. And that's typically they'll use a profile to select a subset. And from that profile, we can then define how are we going to implement security. And so the engineering organization or the software delivery organization that's actually implementing software in production would write a system security plan that says, these are the controls I intend to meet, this is the configuration I intend to use within my system to meet these controls, and then take that into production. And from that, then an assessor and automated tools can make use of assessment plans to measure. And what we're going to hopefully show is that we can use some of those assessment results for visualizing zero trust deployment maturity. Okay, so bringing all this together, we're starting with a controls catalog, and in this particular case, we've chosen NIST 853 controls, which is around 800 different compliance controls that can be implemented. Around half of those are organizational controls, so there's not really any way to automate anything around them. They have to be implemented as human processes within your organization. But around half of the controls are automatable. They're typically their configuration choices or deployment choices within a deployed software system. So for example, choosing to enable TLS encryption on all of your internal traffic in your cluster is a control that implements they can be implemented in the network pillar of a zero trust architecture. We've got a bunch of command line tools in the comply time framework that I described that allow two things to happen. One, we can choose, using a profile from a controls catalog, we can configure the system that this is something posture we want the system to have, and we can also automate a generation of an assessment plan. So that gives the person that wants to start assessing a system a starting point and a plan for all the automatable pieces of assessing that then can be executed on a deployed system. And the compliance operator within Kubernetes can be used for this process. And then we have the compliances code project that I described earlier. That's the compliance content that's coming into this that is consumed by the compliance operator. That's the set of rules that actually implement how to do the assessment to meet an assessment plan. So on a deployed system, compliance operator is running. It's routinely taking measurements of how the configured posture of the system and giving an assessment report. And from that assessment report, we can then either generate, as it was intended to be used, generate assessment reports that an assessor would actually review to see if you're in compliance. But if what you're wanting to do is measure your zero trust posture of your system, then we feed that into a visualization tool and give you some straightforward view of what you're trying to achieve mapped back to those pillars of zero trust I described before, and give you an assessment of how you're progressing versus baseline, and recommendations for what you can do to improve your zero trust posture. And I think at that point we're ready to come on to demo. Yes. Over to you, Arthur.
Wonderful. Let's see. All right. So we are going to be looking at the application that our intern designed over the course of his summer. And first, let's look at the output of compliance operator. As you can see, this is not particularly human or machine readable in a generalizable way. It can be viewed by a dashboard, but this is not yet OSCAL. An example of what OSCAL would look like would be, ta-da, it's much more intuitive and machine readable. So this is what we put into the application. So relatively easy to upload here. And then you can see a list of all of the controls over here. And the pillars that they're associated with, and whether they are passing, failing, and you can also click on them for additional information about implementation, about the control itself, and then some other more useful visualizations. So you can see here in these bar graphs, they are organized per pillar currently. And you can see your current compliance posture in the red here. And then you can select however many controls you want. In this case, it's 3. And you can choose, if you improve those controls, how much it would increase your % compliance, which you see in the gray here. And the application will also tell you which controls they are. So you can see where to best put your effort to best improve your posture. And you can see more information here if you want to filter by baseline. So if you need a very high security, you can see those controls and what you need to address. And then also the diff features. So, you can start with your baseline file, which would be your scan that you take when you first set up your system. And then after you alter any controls, you can upload your ideally improved position and see it visualized in this spider graph. So the red being where you started and the blue being where you have either improved or not improved. In this case, you can see that since the first scan was run, there has been a great increase in compliance for the automation and orchestration pillar, and not so much for network and environment. So it's really a good way to get a high-level visualization of where your system is at currently, so you can make your most effective judgments about how to improve your security posture.
And just going back to the first page you showed. Just to add to what Arthur mentioned, so what we're showing here is that in a complex system, controls are not just satisfied by one thing being done. You may need to measure and check that several like up to 10 or 20 configuration options are all implemented correctly in order for a control to be satisfied. So for example, if you're implementing IPsec in the transport layer of your cluster, then there may be a Kubernetes layer feature flag that needs to be set. There may be some very specific configuration options that need to be set, and the certificate rollovers might need to be set at a certain rate. So there's 3 separate things you need to have configured correctly for it to work and pass control. And what we're showing here is the difference between the red bar and the gray bar is there are partially implemented controls. Then there may just be one more thing you need to do in order to fully implement that control. And so we've prioritized showing the easy to fix things that have the highest impact across your cluster. And so the one that Arthur picked at the top, that's sorted to the top there, is saying this item failed across 10 controls. So if you fix this one thing, then 18 more controls will now be passing on your cluster. Any questions about what was shown in the demo? Okay, we'll switch over back to next slide. So just talking about some future directions here, what we've demonstrated is an application that does this based around the NIST control catalog, and we want to expand that to cover other control catalogs such as the cloud-native controls. Now, we do have a NIST catalog that's annotated with cloud-native controls and with pillars of zero trust and things like that, which is super useful, and that's available in an open source repo upstream, where I've got the links on the final slide of the presentation. So what we've demonstrated what can be done for zero trust, but all of what we've described here, I think, is also going to become relevant for upcoming regulatory regimes such as Cyber Resilience Act, where, again, we want to be able to measure and assess posture of a system in terms of whether or not it's meeting obligations for something like CRA. And there's also emerging new approaches to risk and compliance, which we'll want to adapt to as well. So, for example, OpenSSF has a project called Gemara, where it's a much more risk assessment-based approach to choosing what things to implement in your cluster to meet zero trust, rather than a lot of the controls-based approach and profile-based approach is regulatory regimes saying you must do all of this to achieve moderate level security baseline in your cluster, whereas some of the things in that might not be in your risk profile, so why waste time doing them? So what we want to also explore is introducing some of those aspects into it, so starting with taking you through a risk assessment and then incorporating the results of that risk assessment into how we visualize the current posture of your cluster and what you're doing to achieve improvements in zero trust maturity as you go on. And there's also, within Red Hat, there's ongoing work to build zero trust validated patterns. So we've got an upstream project called Validated Patterns, and I think it's got its own website, probably validatedpatterns.org or something like that, where we've done validated, like deployed architectures with best practice recommendations across other types of architectures and systems, and we're midway through doing one for zero trust in a layered approach. So we've got a foundational layer and then building layers and application layers on top of that, so you can choose how much of the validated pattern you might want to follow in your own organization. And I think, yes, and the last one is, so this is all the links to the open source projects where you can explore what we're working on and you can get involved as well. So the largest content in all of this is the top one here, the Compliance as Code repository, which actually is the implementation of all of our compliance across the regulatory regimes that Red Hat supports in its products today. But that's upstream as an open source project that anybody can access and contribute to. And then specifically for the OSCAL framework and environment, there's a couple of very specific tool sets that we've been working on and working in the community on. One is called Comply Scribe, which is basically an authoring framework for taking content and targeting it into the OSCAL environment and translating between different formats across the regulatory regime. So that's super useful. And then Comply Control is a set of command line tools for actually applying policy into clusters and running assessments in clusters. And that's a work in progress. We've got it running fully on RHEL today, but we don't have it running for Kubernetes, and that's a work in progress. And then moving on to the Zero Trust specific projects, Zero Trust Catalog is the NIST SP853 controls catalog with annotations for the CNCF cloud native controls and for the DoD pillars of zero trust. So that's a really useful way of browsing and understanding controls and what you might want to implement to achieve zero trust outcomes. And it's got a bit of a static web visualization that lets you browse the catalog. And then the Zero Trust Visualization project, the second one there, is the open source project that our summer intern developed. And in terms of our roadmap, we want to integrate that into some of the security products that are upstream, and specifically eventually targeting advanced cluster security in the Red Hat portfolio. But also extend it so that it covers more data sources and more catalog formats. And as I mentioned, extend it to be relevant for risk-based assessment approaches to deploying zero trust. And then finally, the link to the validated patterns for layered zero trust. So if you're interested in this and you want to see how Red Hat are recommending best practice for implementation features, and it's all built on CNCF projects such as Keycloak and Spiffy Inspire for workload identity and so on, then the Validated Patterns project is a great place to get involved. So call to action is just please join in on some of these projects and improve the zero trust posture of your deployed systems as well. Thank you. Any questions?
How would you, just on a wide, on a big picture scale, how would you implement your different IAC tools, internal access control tools within the structure? Or how would that work?
Sorry, I don't quite follow the question.
The IAC, the internet, or it's the internal access control IAC?
Yeah.
How would that factor in by integrating those tools with this platform, so to speak? Or could it?
It could definitely be integrated. I haven't really got a view on that, I guess. So, depending on how you're defining your identity and your primary access control mechanisms in your deployed system, then I guess that would be the integration point. And then there will definitely be controls in regulatory catalogs that exactly map onto that problem space in the identity pillar. I could probably find them if I dug, but off the top of my head, I probably couldn't. Sure.
I guess the other question I have was involving the mandate, CRA mandate. I imagine you're going to be continually updating what you need to know. I mean, right now it kind of remains murky, so how will that play out, you think? And to what extent could we rely on your project specifically to remain compliant with that specific?
Yeah, so it's early days on CRA. There's no it's not early days, but it's early days from enumerating what needs to be achieved from a compliance perspective. So there's no automation yet, but we definitely want to extend into that space, and I think it's going to be crucial for achieving, a robust CRA coverage and capability. But it's early days.
But to what extent can we rely on this, though, to make sure we're compliant? Or maybe it's too early to answer that question.
Well, so much of CRA is actually organizational and supply chain time that it's like runtime assessment is too late in many ways. So we need all of this, but also at supply chain time, understand our upstream exposure, understand what comes in terms of SBOMs, be able to audit all the way up the chain to, and there's other open source projects, and there was a presentation on the Red Hat booth earlier this morning around Project Aspen and 8.0, which is specifically designed around measuring the security posture and health of upstream projects that feed into your software solution. So yeah, there's lots of things that all feed into successfully and reliable deployed systems. And I was just at a talk immediately before this as well, which was around implementing OPA policy for CVSS and EVSS scoring mechanisms, so that you're actually deciding what you want to prevent happening in your cluster because it is a CVE risk. So all super interesting and all relevant to achieving CRA goals, I think. Any other questions? Okay, thank you, everyone.